Welcome to my new calculus channel. My name is John Gabriel, and as you recall, in my previous two videos I was discussing the fraudulent Riemann integral, and so I would advise you to watch the previous two so that you can finally understand the conclusion in this last video on integration. What I'm showing you is really how the new calculus integral, the one that you see here in the middle, is formulated, okay? And it's formulated using the sound new calculus derivative, which you see on the top line here. And of course, all these things can be proved. The proof of these can be found in my free ebook, An Introduction to the Single Variable New Calculus, which I will place a link to in the details section of this video. You can see first of all, the mean value theorem and its proof in chapter 9, and then of course you can study the new calculus integral in chapter 12. Okay, so now what I'd like to do is discuss the so-called concept of infinity. There is no infinity required in mathematics. It's a junk concept. So when I say the arithmetic mean of all the vertical line lengths in this interval, to you, that would seem like there are infinitely many, okay? And therefore, it's impossible to calculate the arithmetic mean. But because of a special property of the mean value theorem, or actually not even of the mean value theorem, of smooth functions, but because of a special property of smooth functions, it's actually possible to do that task, even though it is in fact a super task if you had to try to do it in any other way but by the conclusion of the mean value theorem, which says basically that the arithmetic mean here is equal to the boundary of the difference of the boundary means of the primitive function divided by the interval width, from which the fundamental theorem of calculus is derived in one step, right? As you see in here. So this f prime of c is the arithmetic mean here, and this f here would obviously be the primitive function of this quadratic that you see up here. Okay, so f would be the primitive function of this function. So study the previous two videos to get a better understanding, and this is really how the area and volume and everything else in calculus is determined through arithmetic means. It has nothing to do with infinity. It has to do with the property of smooth functions, smooth surfaces, okay, and so on. So let's close that and come back here. So as you see here, it doesn't really matter what the interval width is. It always gives you the correct arithmetic mean because we're looking at the difference in these boundary values. So you see the difference in this blue line length and this short blue line length will give us the area under this curve here. And it shows you here on the right hand side using the new calculus definition, okay, that it doesn't matter what k is. And by the way, k is finite. There's no infinity. You can take k is equal to 2, k is equal to 3, 4. It doesn't matter. This value here that you see down here, 22.298, will remain the same, okay? Do you see that? No change, all right? Doesn't matter how far you go. This is true because the new calculus theorem here states that this sum is telescoping, which means that it gives us all the terms in the middle cancel out, and we only have the two boundary values. And so there is no need for infinity in mathematics or any other field of rational thought. And the new calculus is based only on well-formed concepts that can be derived from a void universe where there is no need for axioms, postulates, or any other kind of belief. Everything can be systematically derived. The new calculus is the first and only rigorous formulation of calculus in human history. And because perfect knowledge is never invented, only discovered, it's quite possible that aliens already know this information. but only the fools in mainstream academia continue to reject the wisdom that I share with you in these videos and in my free ebook, for which I'm not even gaining a single penny. And yet this free ebook here is the most important mathematics book ever written in the history of humans. Okay, so I would advise you to read it, study it, and learn everything you can so that you can understand calculus and become better at it. Well, I hope that you've enjoyed this small little presentation and that you'll join me again for another interesting topic in the future. This is A New Calculus, and I am the great John Gabriel. Till next time, goodbye.